The universe is the grand tapestry of mysteries, woven with stars, galaxies, and the endless quiz for knowledge. Every discovery brings us closer to understanding our place in the cosmos.
With this spirit of exploration, I'm delighted to welcome you all to this student interaction session with Dr. Annapurni Subramaniam, Director, Indian Institute of Astrophysics, Bengaluru, hosted by the Astronomy Club of BSc College of Technology. As the Director of the Indian Institute of Astrophysics and the first woman to lead the institute, she has made groundbreaking contributions to astrophysics. Her expertise in stellar evolution, star clusters, and galaxies continues to inspire the scientific community. It's an honor to have her with us today, sharing her insights into the vast cosmos. Everything begins with the mother. She creates, guides, and shapes us. With gratitude, let's honor our motherland. I kindly request everyone to stand for the Tamil Thai Valttu.
I invite our esteemed principal, Dr. K. Prakasan, to address the gathering.
Please. Good afternoon, respected chief guest for this interactive session and our tech day. Dr. Annapurni Subramaniam, Director, Indian Institute of Astrophysics, Bangalore. HODs, faculty members, dear students from Institute of Astrophysics, Dr. Annapurni, and to clear your queries on space. You know the space. We know oceans and rivers. We know optics partially. We know about called space. The 5 elements. The element is little bit which we don't know. Comes our mind. So the deepest point in the that is in the Pacific Ocean, but the deepest point in space we don't know. Space is like a situation of it is silent, but it is always sending so much of formation. So if you know the formation of the universe, you will know things out of it. I have read something on astrology, and how life is influenced by exploration of science. People who think R.K. Fowler and such people, Chandrasekhar, Nobel laureates, such people, so they are all things we comprehend. You use a word called unthinkable. So with this, I time because time is serious for interaction. I welcome Dr. Annapurni Subramaniam for this interaction. Thank you for the request. Last year we tried. So with a great applause, welcome. My most important, I told children of school should sit in the front row, speak to madam, get your passion inspired and kindled. This is the right time. This hall is quite famous because the first cosmonaut of India, Rakesh, he spoke in this auditorium, but the stage was there. Then the former chairman ISRO, Dr. K. Even also spoke here. So now this is the next eminent personality who is going to address you. With this, I request Madam to start the interactive session, and I think there will be some small questions, then you can raise your queries. Thank you for giving me this opportunity.
Thank you, sir, for your insightful and inspiring words. Now I invite Jessica V to formally introduce our guest to the gathering.
Good afternoon, everyone. It's an absolute truly honored to have a remarkable science and inspiring leader, Dr. Subramaniam, Director of Indian Institute of Physics, Bangalore. Welcome you, ma'am. Dr. Subramaniam once beautifully described all the astronomers as light hunters, someone who chases the light from distant stars and galaxies to uncover the mysteries of the universe. To her, astronomy is not just a profession, but a passion. With over 3 decades of research experience and around 175 scientific publications, Dr. Subramaniam has made significant contributions to various fields, including star clusters, stellar populations, galaxies, and ultraviolet astronomy. She played a key role in AstroSat, India's first multi-wave telescope, led the development of visible emission line coronagraph for Aditya L1 to study the sun's inner corona. Currently, she serves as the principal investigator of INSIS, the next generation UV optical space telescope. Her leadership and scientific vision have earned her numerous prestigious awards and honors. The Rashtriya Vigyan Vigyanji 2024 in Space Science and Technology, the C.V. Raman Young Scientist Award 2018 from Government of Karnataka, and many others. Today, as we celebrate her achievements, let us be inspired by her relentless pursuit of science. It is truly an honor to have her august presence in our campus. Please join me in giving a warm and heartfelt welcome to our guest of honor, Dr. Annapurni Subramaniam.
Thank you, Jashita. I now invite our honorable chief guest to preside over this interaction session.
Vanakkam. Good afternoon. I'm very happy to be here, and I'm thankful to the organizers as well as the principal for inviting me here. Apologies for not able to come early, but today also apologies for shifting the program because time is not in my hands. I'm not deciding what to do because there are some meetings coming from higher ups. So I'm sorry for that. I'm happy to be here, and I would like to share my journey for the first 10 minutes or so, and then we'll be opening for questions, because I don't want it to be a monologue where I tell you and you listen. I would like to know what you think and what you want to find out from me. So that is why we are here. So please bring up your questions. I am happy to answer how much ever I can. So to begin, I'll try to speak in Tamil, but I'm not a fluent speaker in Tamil, but நான் வந்து படிச்சது இதுக்கு இங்கேருந்து ரொம்ப தூரத்துல இல்லை, பாலக்காடில். ஸோ நான் அங்கே தான் ஸ்கூலில் படித்தேன், அங்கே தான் காலேஜில் படித்தேன். ஸோ I did my college education in Palakkad from Government Superior College. So அங்கிருந்து தான் நான் wanted to do continue in physics. So ஸ்கூல் வந்து மோயன் கேர்ள்ஸ் ஹை ஸ்கூல். அங்கே 10th முடிச்சதுக்கு அப்புறம் நான் விக்டோரியா காலேஜில் ப்ரீ டிகிரி முடிச்சு, அப்புறம் பிஎஸ்சி முடிச்சு, எம்எஸ்சி அது வரைக்கும் அங்கே தான் படித்தேன்னா. அதுக்கப்புறம் நான் மேலே என்ன படிக்கணும்னு யோசிச்சிருக்கிற டைமில், பட் ஒன் திங் வெரி clear to me, I want to study more. And I was very worried that I will not be able to study. So I started writing exams for that I have to prepare by myself, and which with not much of information is available in the internet era, but I have to study by yourself. So any advertisements varum ketana newspaper advertisement varum, not in the internet. So you have to apply through the newspaper, and that's how me and Shana, who's a good friend, Prakashan, we were together in college, and we two actually went to IIT Chennai and we got into MSc. Both left IIT Chennai, and I came back to Palakkad to do my master's. That's a different story. But he went to ISc and started doing his master's. But I went again back to Bangalore to start my PhD. So that is possible. I'm not that I'm saying I'm great, but that is because of the hard work. Hard work is very important. Focus is very important. நீங்க இங்க இருந்து வந்துருக்கீங்க, இந்த ஸ்கூல்ல படிச்சிருக்கீங்க, அதனால உங்களால பண்ண முடியுமா முடியாதாங்கிற கவலை உங்களுக்கு இருக்கும். பட் கட்டாயமா உங்களால முடியும். ஏன் பண்ணணும்னா you have to focus and you have to work hard. These two are very important. Focus and work hard are very important. That way you can reach anywhere you want. That is your wish. Okay. So after that I started doing my PhD, and this is the place where I started doing my PhD. But after doing my PhD also, I could not go outside because of various reasons. I continued the same institute as a faculty, but that is also not an embargo, because I could rise up to the director. And not only first time, I've been appointed second director. So I'm doing something good. So I'm happy about that. So definitely, if you think you want to do, you can do. So it's all up to you to decide how you want to spend your time, and how you want to work hard. So work smart. It's not working hard means looking at the book and sitting for 5 hours is not going to help you. You set a timeline. In half an hour I'll complete this, and by the time I should know this, understand this. So put a timeline and activity timeline as well as what you want to do in that time. Then only you can achieve. Volume is large, so you have to be focused. That's why focused and hard work are both together you need to do. Before getting into that, I'll just give you a tour of what Indian Institute of Astrophysics is, so that we'll get to the topic. Okay. So this is the picture. Just go back. This is the picture of our observatory in a place in Ladakh. It's the north of India. Okay. So this telescope is situated at a height of 4,500 meters above the Himalayan Chandra telescope. Now, why are you trying to go all the way up there to do it? Because astronomy needs clear sky. So this is a place where you get clear sky. See, all observatories are in places where you get clear sky. Okay. So this one observatory we are running in Ladakh. Next thing. Now, what are we? I hope you can see the screen, or please adjust with that screen, how much ever you can see. So we have a lot of footprint in Tamil Nadu, because our observatory started in 1786, and between this period and where this was a Madras observatory established in 1792. Okay, and then it was moved to Kodaikanal in 1899. Still, we have the observatory in Kodaikanal. The Kodaikanal observatory is operated by us, and this is 125 years old. So still, you can, if you're going to Kodaikanal, you do visit. There's a museum, you can go see it, and that gives the history and also general overview of astronomy there. Then we became Indian Institute of Astrophysics in 1971. Then we established several centers, and we are under the Department of Science and Technology. I'll give you a tour of all these observatories, so you can give an idea of what we are doing. Next slide. So these are our footprint. We have a head office in Bangalore. That's why I sit. Then these are our field stations. I already mentioned about Kodaikanal. We have an observatory in Kavalur. This is Vainubappu Observatory. This observatory is close to Vellore Vaniyambadi region. Even you can go there and offer a day visit. That's possible. I'll also show you overall, sky view of that particular observatory. We have these stations in Karnataka. It's Hosakote, where we have Space Sciences Lab, and Gauribidur, this is a radio observatory. We are also setting up a planetarium in Mysore. That's a coming up thing. This is on the ground. We also put telescopes in space. How many of you have heard of Aditya L1? Raise your hand. Okay, Aditya L1 was a mission, space mission to study the sun, which was sent too long back. You probably would have read it in the newspaper. And that mission, the main instrument is built by us. So this and these are our space programs. We also have a 30-meter telescope project which is going on. Next slide, please. So this is our observatory in Ladakh. You can see what you all notice here is that, can you see any green there? It is not green at all, right? It's like a very barren, it's like a desert. You know why? It is a very dry place because it is at altitude of 4,500 meters above sea level. It's very dry and there's no vegetation. That is very good for astronomy. But only thing is there's hardly oxygen. So it's not easy to go there and spend time. So we operate this telescope remotely from Bangalore. There are two telescopes. One is here 2.2 meter. This is a 0.7 meter. It's a 70 centimeter telescope. This we operate jointly with IIT Bombay. We also have a Nare Gamma Ray Observatory on the foothills. This is 4,200 meters. This is a Gamma Ray Observatory with Tata Institute of Fundamental Research. And this is a big 21-meter dish by Baba Atomic Research Center. So these are all Gamma Ray observatories. So there are a lot of observatory here. Next slide. It's a video. So this is the aerial view of the observatory, 2-meter telescope. And we go into the 2-meter telescope now. So this is the telescope, and we have these back-end instruments here. The instruments which are taking data, many of them are shown here. And all these are remotely operated from Bangalore. And how do you? Okay. So this one is the instrument down. This is the GIT, a 70 centimeter telescope with IIT Bombay. This is actually automatic telescope. This is other Hagar array which is on the ground, the base station. This is actually 7 together. This is the MACE, 21-meter MACE, which is a big instrument there. And they're all run by solar panels. We don't have a power grid there. And this observatory is operational for the last 25 years. And the huge PMT, the photomultiplier camera. And so the overall layout of the observatory, and up, this is the ground facilities, this is the up facility. So the entire observatory there. Go next one. Next slide. Yeah, I think you got to press again. Yeah. So this is our Kavalur observatory. You can see the sky view of all the telescopes. This is the Vainabapu telescope. This is a 2.3 meter telescope. This is indigenously built. People can actually go there, and we conduct activities on the ground. So on the floor itself, you'll be able to see that very nicely. Next slide. They have a video there. Yeah. So this got disconnected, doesn't matter. So this is the not seen. Yeah. So can you just go to the front? Yeah. So these are the main telescopes. 4 or 5 telescopes are there, but you can see the difference. It's quite big, isn't it? So it's southern is not very high altitude, so that, but we will see the southern sky. That's the advantage. If you want to go and see this, you're welcome to do so. Write to us. We'll arrange a tour for you. That's possible. Next slide. Yeah. So in Kodaikanal, what we do, we take the pictures of the sun. Now, what do we do why do you want to take the pictures of the sun? Because sun has got something called sunspots. Now, the sunspots, you can see them. And do they stay stationary? No, because the sun rotates. When the sun rotates, you can see the sunspots moving, right? So this is how we know the sun is moving. And sometimes it has a lot of sunspots. Sometimes the sun has less sunspots. You have to ask why, right? That has to do with how the sun is producing energy, how the energy is coming out of the sun, how the energy is reaching us. All these are combined. Now, when the sun goes into a flare mode, then that also creates why the sun is having flares, why should we even care about flares, right? So those things are there. Now, we have been operating from 1904 onwards observatory. Now, what have we been doing from 1904 onwards? We are taking the pictures of the sun. So what? What do I care about it? We do care about it because if you want to study the sunspots keep changing. They're not happening at the same place. And now if you want to study it over a time scale, we have data over 120 years. You can see this data which is plotted as like the sunspot area is plotted. You can see nice butterfly here. You can imagine butterfly. This is the famous butterfly diagram. Now to make one butterfly, you need 11 years. 11 years data is required. So if you want to continue understanding it, you need 11 into something data. Now since we have 20 years of data, you have 10 cycles, at least you can study and see all these 10 cycles. Now do these 10 cycles look same? No, it's different. So something is different happening in each cycle. That asks you questions like why is the sun not the same every day? Why is the sun changing from year to year? Why is the sun changing over a period of 11 years? All these are questions we need to understand. So that is what we do there. Next slide. So we also study the outburst of the sun using radio. That's for another talk. Yeah, this is in Gauri Bidanur. Next slide. Now we also run several big machines for space telescope that is in Hoskote. We also make big mirrors that is in our Hoskote campus. Next slide. So this is a one mirror testing method. This is a video. You can play that video. Yeah. So this is the large mirror. In the telescopes you have to make mirrors. So this tells you how this mirror is made and how the mirror is tested. So these are big machines and very precise and carefully you have to handle. You remember these are all glass. So you have to very carefully handle. So this is measuring, touching and measuring the surface accuracy. So these are sophisticated machines, and this is right now the fabrication for this is getting ready. So what I'm trying to say is that astronomy has a lot of engineering involved in it. You can see these big machines. You have to design it, make it, run it, operate it. So astronomy is driven by highly complex engineering machines. We do that, and this is the whole machine. This is the actual actuators for it, and then this is being tested. And this program, the 30-meter telescope, this is not the actuator, but eventually when it is made, these mirrors will set on certain supports, and the supports is actually made in Coimbatore. The supports for all the 492 segments is being made by L&T lab in Coimbatore actually. So this is a connection to Coimbatore as well. Yeah. This is the roundel testing. This is warping, and then this polishing is a highly technical thing. Only a few countries in the world know how to do this. Yeah, I think you can move. Yeah, so this is the profilometer. You can change it. Yeah, so this is a UV imaging telescope experiment. Yeah, and galaxy pictures are there. This is the coronagraph which is flying on Aditya L1, which is already completed more than a year in orbit. This is 1.5 million kilometers away from us, towards the sun. Yeah, it is 1% of the distance to the sun. Yeah. Next one, we are also having major projects in the planning. So these are some of them. That's all. Yeah. So we also do a lot of research activities which are encompassing all aspects of sun and solar system, stars, instrumentation, cosmology, external galaxies, etc. Yeah, that's all. Thank you. We'll leave it here, and I'll take questions.
Thank you, ma'am, for your invaluable insights. Your words were truly motivating. Now comes the most awaited part. The student interaction session. Our chief guest will answer questions submitted by our enthusiastic students. If we consider the universe as a system thermodynamically, what is the surrounding? If we consider the universe as a system thermodynamically, what is the surrounding and what is it expanding into?
Yeah, it's a brilliant question, but we don't know the answer, because when you ask a question like, okay, we know the origin of the universe, look back time, and you say it's a Big Bang, and this is a soup of all particles and energy together, right? After some time, the particle and the energy disentangle. sorry, then the universe started expanding. Now, if you ask me what is the universe expanding into, that is the question which is being asked. We don't have an answer. So we still have to look at how big was it, what is beyond the universe is what is you are asking, right? Because if you have a system, that means you have a bubble, it's expanding into the room. There's already a room full of gas, and this bubble is expanding into the gas in the room. Now, we do not know whether the room exists or the gas there exists, so we don't have an idea. We only know this bubble, which we call as the universe. So that's where we stand as of now, from experimental estimations.
What are the biggest unsolved mysteries in the astrophysics today, and how can young engineers contribute to solve them?
Nice. So as you saw these big machines being made and used, right? So you will ask me, why are you making it? Who told you to make it, right? Why do you make it? Who told you to make it? What are you going to do with it? So astrophysics questions are the ones which drive you to make this thing. So there are, like, you know the James Webb Space Telescope. How many of you have heard about the James Webb Space Telescope? Okay. So why do you have the James Webb Space Telescope consists of not one mirror as the main mirror. It has got 18 segments. Now you have to lift these segments, put it at 1.5 million kilometers, and do some huge engineering to it. It's a huge engineering marvel. Now why are you doing it? Because exactly the answer they're seeking is connected to the first question. The first question is that how are you? Why do you know? What do you know about your past? How did the universe begin? How were the galaxies when the universe began? So how can you look back in time? How much can you look back in time? So this is a question being answered. Now, it is difficult to say what machine will look back in time, right? So you have to design that instrument, and you have to have a scientific procedure to do it. By doing this, I will be able to look through and see that this galaxy is formed very early in the universe. Now that science question led to an engineering marvel like JWST. It is in space and it's giving you data. Now the question is, did you answer the question? Yes, we are able to see the galaxies up to about the first 300 million years. That's all we have gone up to now. So the biggest science question is, one of them is the early universe, how the universe was like. Second thing is our own neighborhood, like we know that there are planets around other stars, right? Your question is, are there habitable planets around other stars? How do we know that? What is the chemistry of those planets? You cannot see the planet because it's like, you are trying to catch a molecule in a room. It's not the same, but it's as difficult as that. So you have to figure out a method, very smart method, very clever method of catching that. So these instruments are tuned to do that. There are several questions, astrophysical questions, and each question requires a huge, like there's a dark matter. Are we going to dark matter? We don't know what our dark matter means. So there are many machines being created. To create all these instruments, engineering is required. So astronomy is driven by technology, and astronomy also drives technology, because these questions nobody else will ask. So engineering, all these machines. This requires optical engineering. This requires mechanical engineering. This requires electronics engineering, as well as computer engineering, because the software is required all throughout. So all engineering has a role to play in space sciences. If you want to launch a telescope, if you want to launch a rocket, all these are also important. So starting from launching a rocket or making these instruments, engineering is extremely important.
The next question. If you could safely pass through the event horizon of a black hole, what would you see? And could it be a gateway to another universe?
Well, again, so it is, I mean, the question appears like, the picture, there's a hole there, you just walk into the hole, and can I get to the next room? That's the question being asked, right? So the question is, can you walk to a black hole? Now, imagine even walking on the surface of Mars or even Moon. The gravity changes. There the gravity is less, okay? But if you go to a black hole area, the gravity becomes very, very strong, and it changes drastically. So you eventually is like spaghetti, like that's what people think. So you don't even think of walking through the thing, but the matter gets ripped apart. So you do get ripped apart. We really don't know what will happen, but thing to do because of the gravity. Yeah.
If you had unlimited resources for the research project, what fundamental question in astrophysics would you most want to answer?
Yeah, so I want to answer or the community wants to answer are two different things. If I have unlimited resources, there are very lot of pet projects which I would like to know, like how the gravity changes when you go to space-time. You can send a probe to one of the satellites of Jupiter to find whether there's any life there. So many interesting things can be done. So a lot of interesting things can be done with unlimited resources, but resources actually, sometimes restriction resources also make you find clever ways. Some restrictions sometimes make you clever ways, otherwise you wouldn't have thought through that clever way. So I think some balanced resources is required to get an efficient way to do it. Yeah.
Composition structure of planet's core influence its magnetic field? And what are the implications for habitability?
Yeah, so there are two parts of the question: the composition and structure of the planet core and its magnetic field. I'm not an expert on this field. The core has to be at least of magnetic material to be even, it has to be plasma. What is magnetic field? Magnetic field has to exist through something, then it has to be, I don't know which class you are in, it's to be ferromagnetic material, right? So you have to have a ferromagnetic where you can actually, magnetic field can pass through it. So, to sustain, you have to have some ferromagnetic stuff. That's what we understand. Or you have to have plasma, ionized material. So one of these two have to be there to do it. So wherever it is there, you will have magnetic field. Magnetic field is permeable. That's all. Implications, of course, it's a huge implication. We haven't found a Earth-like planet. We have found an Earth-like planet, but not like Earth-like atmosphere. Earth-like conditions we have not found. If you find it, it's huge implications. If you can travel to it, you can probably go there and live. Maybe, I don't know. So those things are like, the bigger question is, how did the life originate? That's a very, very important question. We don't still understand. You have this inorganic, organic molecules, etc. Where exactly will how exactly the life started? So that's an extremely important question. We haven't answered it yet. So, of course, it's got huge implications.
How will the recent acceleration of the dark energy affect the stellar population?
Stellar population and dark energy is not directly related at all. Dark energy is the expansion. So you're basically trying to say that how far things are, sometimes suddenly acceleration happens. So it's a cosmological constant, if people understand it. That is what people had put in. But now with the new data, we realize that maybe that's not constant time. So it's varying with time. So it gets more and more complex. So what we had stellar population is what the galaxies actually have. So they are not directly related as such.
What's the most exact discovery or experience you had during your internship or research? How did it change the way you see astronomy?
Yeah, so as of now, I think the experience I had in Kavalur Observatory, because when I joined a research project of astronomy where I spent time looking through the telescope and collecting data. The data to address a science question. So that's what I did, and I spent about 4 or 5 years, most of my time spending in Kavalur. It was a lot of work. It was a lot of hard work. So I liked it. That's what I did. I was not thinking that how will I use that time to climb up in my career. That was not the thinking. The thinking was I'm liking it. I want to do it. But looking back, that experience gave me enormous how instruments work, how an observatory will work, how do you sustain it, all these things. With AstroSat, the UV imaging telescope, which we saw, I was and I worked on it for about 7-8 years before launch, and after launch about 5 years. So I've contributed immensely to it. That satellite is up in the space for the last 10 years. So Those two are given me a lot of understanding and changed my astronomy. Yeah.
With the growing role of AI in many sectors, how do you see its impact on astrophysical research in the coming years?
So the artificial intelligence learning part, right? So these are the buzzwords now. Now, you know what? I used machine learning, like the neural network, for my PhD. So astronomy and machine learning and software has been traced long back. And I classified the spectra which I studied, obtained from Kavlur using neural network. So the astronomy has been driving the ML and AI, but not the way it is done. We don't have language models, which is for the common use. But we have models and we have a lot of software which run on data. Because astronomy in the now is data deluge. And all the data is actually curated data. No other field gives you ready to use data. Astronomy gives you ready to use data. So nowadays, if you see the last even more computer scientists are making papers in astronomy. They have data and they use their algorithms. So astronomy is AI and ML is not new to astronomy, and there are many things which actually help to develop many algorithms in AI ML in the past.
Why is our universe mostly made of matter and not equal amounts of matter and antimatter, even though they should have been created in balance during the Big Bang? Is it possible that an antimatter version of our universe exists somewhere?
Yeah, so we don't know why there is only matter and there is no antimatter, and that is what all this question related to finding what happens in the past. So we have taken one path and we have gone ahead. What happened if was there a different path? If you take that path, will you reach another universe? We do not know. So we have to go look back time and then explore and find out what was the position, why the matter dominated antimatter and we have a matter dominated universe. We do not know. We have to, that's a question. There are theories which say that there is antimatter universe. They're all theories. You can have a lot of, simulations and predictions and ideas. But all these ideas exist, and until I prove it, you cannot say that it's right or wrong. You need data and observation, the experiment, find out what actually existed. But of course,
is it possible for a black hole to evaporate completely via Hawking radiation?
I don't know the answer to this question because okay, we have a question here. It's possible, but I can't. I don't know. I'm not a theory person who works on black holes, so I can't understand this question. Yeah, I can't answer this question. I have these questions here. I can read it out. So, how does mass affect stars' evolution? That's the next question. That is a fundamental thing, actually, because the way the sun is the way it is because of its mass. Why? Because the mass is what gives it the. It's like larger mass can actually the gravity can collapse into a big star with the central temperature being very high. How is the sun producing energy? Because of nuclear fusion. If you look at 8 times the mass of the sun, 8 times the mass of the sun, then what happens is the core can produce up to iron. But if it is less, it can produce only up to carbon or oxygen. So depending upon the mass of the star, the core nuclear fusion can produce certain metals. So the mass is extremely important in not only the evolution, but also production of elements. All the elements in the universe most of it is coming from, all the elements higher than beryllium, lithium, etc. are coming from stars. So if the stars have to make all these elements, they have a range of mass.
How can students get involved with research projects at IAA or other institutions?
Yeah, very relevant question. We do run several programs, visiting student program that is for doing research project, that is for higher classes like master's students in science or even MTech students in science. For the BTech and the BSc final year, etc., we run summer schools which are done in either Kavalur or Kodaikanal. We do have online summer schools where even lower classes can participate. We have something called, you can visit the observatories anytime to do it. Doing a project during summer is not possible because we don't have a large number of people who can support large scale, but there are a lot of online material, etc. You can do it and do visit the observatories, and you can write to some people where we can hold some lectures and some interactions, etc. Or we can provide some material to you where you can read up and understand, because at this level, as smaller levels, you need some reading project or some small hands-on project can be initiated. Yeah, thank you.
I request one open question from Sarvojana.
Hello, ma'am. I'm Srinata from 9th. Pluto became a satellite recently. So, how is there any chance that any other planet can become a satellite like Pluto?
Yeah, so the question is why Pluto became taken out of the planets, right? 9 planets. Now you have 8 planets. So it's like the following. How do we know? We knew planets were existing in the solar system, but we knew only one solar system. But in this century, around 2019, 90s, late 90s and all that, we started detecting planets around the other stars. And we also started detecting solar system around other stars, like in the sense, many planets around it. Now, if you start looking at, if you see another house coming up, you will see, how is that house compared to my house? What is different? Like that you start comparing, right? So we also started comparing. Then we started realizing that Pluto is actually more tilted than the rest of the planets. It is looking different. Since it is also another object in the external object, we consider it as planets. But if you look at nearby neighboring solar system, all of them are in the same plane. And we cannot consider that as a planet. So if you want to classify other groups when it is coming, if you want to say it is a house or a building or a convention center or a marriage hall, you have to have certain framework. So when the framework is constructed like that, Pluto became out of the thing because of certain characteristics.
Thank you, ma'am.
Now, I request one open question from PSG Public Schools.
Good afternoon, ma'am. Given your work on stellar formation and galactic evolution, how do you reconcile the high probability of extraterrestrial life based on cosmic abundance with the total silence that we observe? Where do you stand on the Fermi paradox, and which possibility keeps you up at night?
Oh, many things keep me awake at night. Regarding extraterrestrial life, the way the life is, we know only the one we have it here, but we haven't detected any signs of life elsewhere. Now you have to be a little more imaginative than that, because life may not be it as to perceive it, right? So we are looking at signals like SETI Institute, Extraterrestrial Intelligence Institute, has been looking for life. They've been looking for radio signals, we're looking for various other signals, etc. We have not been able to come up with something conclusively to say that there is extraterrestrial life existing. But another problem is also there, even if there is a life existing very far beyond, by the time you communicate the problem, would have gone. So we do not know with far beyond it, the life, it's like a blip in the entire evolution of the universe, a slight blip. If that blip comes across you, you will see it. That blip might have gone, so you will not see it. So it's a lot of complicated processes coming together.
Thank you, ma'am, for your insightful response, and thank to our students for their thoughtful questions. I invite our principal, Dr. K. Prakasan, to present a memento to our esteemed chief guest.
Thank you, ma'am. Thank you, sir. Now, I invite Mr. M. Shaileshwaran to extend a heartful vote of thanks.
Good afternoon to everyone present here. I am honored to deliver the vote of thanks on behalf of PSC College of Technology. I extend my deepest gratitude to our esteemed chief guest, Dr. Annapurni Subramanian, Director of Indian Institute of Astrophysics, for taking time to be with us today. Your insights into astrophysics and space research have been truly inspiring, and we are privileged to have had the opportunity to learn from you. Your presence has made this session both insightful and memorable. Thank you, ma'am. I also express appreciation to our respected principal, Dr. K. Prakasan, for his continuous support in organizing such impactful academic events. His encouragement fosters a culture of learning and exploration at our institution. Thank you, sir. I also, a special note of gratitude to our dedicated faculty members for their efforts in making this event possible. Special thanks to the College of Technology, PSC Sarvajana Higher Secondary School, and PSC Public School. Thank you all for your enthusiastic participation. Your curiosity and thoughtful questions have added immense value to this session. I extend my heartfelt thanks to the volunteers of Astronomy Club and everyone who worked tirelessly behind the scenes to ensure a smooth execution of this event. Your dedication and teamwork are truly commendable. Once again, thank you all for being a part of this wonderful event. I look forward to making such opportunities for learning and collaboration in the future. Thank you. Thank you, ma'am.
Thank you, Mr. M. Shaileshwaran, for beautifully conveying our appreciation.
I extend my deepest gratitude to our chief guest, Dr. Annapurni Subramaniam, for gracing us with her presence and wisdom. A heartfelt thank you to everyone who joined us today for this wonderful session. I now request everyone to rise for National Anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कलंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
We truly appreciate your presence and participation. Let us continue to explore, innovate, and reach for the stars. Once again, thank you all for being part of this memorable event.